Good afternoon, grade 11s. Can you hear the ice cream truck travelling past? Poor ice cream salesman. Imagine trying to sell ice cream in the middle of winter. Okay, so this lesson is to go through the practical that you did on age and near point. I hope you put some good effort into doing this. I'm just going to go through the memo with you. So the graph should have been a line graph because that best shows the trend of increase in near point with increasing age. I hope that you did a line graph. Remember that a line graph can only be used for continuous quantitative information on both axes. So more or less the kind of marks that would have been given were a mark for the heading. You have to do a heading for every single thing that's a diagram, a graph, a table, a flow diagram, a timeline, etc. Just don't think about it, just do a heading. And that heading must be complete. It must indicate all of the information that is shown in the graph. So it's not okay, for example, for this particular graph, to say a graph of the results of the investigation. You need to say what is on the x-axis, and you need to say what is on the y-axis, and the fact that the graph is showing the relationship between the two. So a graph showing the relationship between the age of subjects and the distance of their near points. Okay, line graph. Correct axes, you would put the age on the x-axis and near point distance on the y-axis. Both axes must be labeled. There must be units on both axes. So years on the x-axis and centimeters as the units on the y-axis. In life sciences, you always start with 0, 0 at the origin. But remember, you do not start your line at the origin. You do not know that at 0 years, near point is 0. Okay, there's no indication of that. So even although the graph starts at the origin, 0, 0, your line would only start at 10 years. The near point distance is 9 centimeters. So that would be your first point, and then the graph would go on from there. The only time that you would extend the line back to the 0 on the x-axis would be if they asked you a question about that. So they might, for example, say in a question, suggest what the near point would be at 1 year or at 0 years. And then what you would do is you would follow the trend of your line backwards, and at 10 years, just keep on going back at that same slant. And it's not going to go through 0 and 0. Okay. Then you need to have a sensible scale. Remember that most graph paper has got a big block with 10 little squares and maybe a thinner line at 5. So you should be working in units of 5s and 10s. Now the age is very easy because it goes from 0, which you have to start at the origin, to 60 years. be careful, read through all the questions. They might say something like extrapolate and suggest what the near point, published near point would be at 70 years. Then you need to leave enough space on your graph to go through 70. Okay. The scale should spread the data out over most of the graph paper. And then I'm obsessive about this. You must put tick marks on the axis line. That means if you on the x-axis have got the figure 10, then you need to put a little tiny mark on the x-axis line to show where 10 is, and where 20 is, and where 30 is, etc. And also up the y-axis. And then a mark or 2 marks quite often for whether you plotted the points correctly. Now this is a favorite question. Describe the relationship or describe the trend shown by the relationship between the distance of near point and age as illustrated by the graph that you drew. Now remember that what you do if they ask you to describe the relationship or describe the trend shown by the graph, you describe what the line on the graph is showing. And everywhere where there's a change in that line, mention figures. So near point distance increases very slowly as age increases. But the rate at which it increases slowly because the graph is not perfectly horizontal. It actually starts to go slightly up because between 10 and 20 years it goes up by 1 centimeter, and between 20 and 30 it goes up by 3. So the slant is going up, but the increase in gradient is slow. Now you can only say slow because there's a time aspect here. So the increase is slower until 40 years of age. And after 40 years of age, the rate of increase increases. And this is a strange concept. It just means that the line is getting steeper. So the rate of increase, which is the line, increases significantly. In other words, it starts to get much steeper. Although in fact the increase in rate is almost constant because between ages 40 and 50, it increases by 32 centimeters in 10 years, and between 50 and 60, it increases by 33 centimeters in 10 years. I hope these figures are correct. Tejo will attest to the fact that my arithmetic is absolutely appalling. Anyway, okay. So then you had to determine the near point of 5 people, and you numbered them 1 to 5, and you plotted it in a table. Now, it said right at the beginning, you must read through this entire thing before you start, because that table is not as simple as you think. So the table then needed to have the age. You could also have included the number of the subjects because you numbered them 1 to 5. The determined near point, that was what you measured. The expected published near point, that's what you read off on the graph. So if you found a person who was age 33 as a subject, then you would go onto the line on the graph, and at the point 33, you would read that little expected near point off. So you would read it off of the graph. And then you had to calculate the difference between the determined and the expected near point. And remember, that was a positive or a negative, depending on whether it was closer or further away. Okay. Then you had to plot your graph, your points, numbered 1 to 5 on the graph on page 2. just to show the difference between your points and the published points. Okay. Now, this is a higher order question that you must make sure that you learn how to get these ones correct. Is the published correlation between near point and age accurate? Suggest reasons for this and explain how each of your given reasons might cause a discrepancy between your readings and the actual published readings. Okay, so your answer depends on the data collected. It's unlikely to be the same. And the reason why is there are lots of reasons. The sample size was really small, and therefore the data would be unreliable. You only did it on 5 individuals. You only did it on one eye. It might not be the dominant eye. If you started off choosing somebody's right eye, then everybody had to be done on the right eye, and it might not be the best eye for each individual. In fact, you might have taken a person who was blind in the right eye, in which case you're not going to get a good reading there. Some of the subjects may have had vision problems that were not taken into account, and there's no indication, however, that this was taken into account with the published data. And then lots of other relevant points that you could have used. There's no indication in the method of how rapidly you have to move the pencil towards the subject, or that the subject needs to move the pencil towards their eye. And so it might have been much faster from one person to the next person, etc. There are lots of reasons why it might not have been accurate. Okay, and we would have marked relevant points. Be careful, bullet your points, because it says, no, it doesn't say how many reasons. What did I want to say? Oh, okay, 15. What is the independent variable? The age. What is the dependent variable? The distance of the near point. Okay. State 2 fixed variables in this investigation and state how each was fixed. So a number of possible answers that you could have given here. Now the IB never, and that's what I meant to say for the previous one, never marks 2 that are similar. You're only allowed to mark 1 of 2 that are similar. So if you are talking about the eye, then you could only use 1 that describes the eye. So the same eye was used, it was determined up front, and it was used for all the subjects. The instrument used to determine the near point was a sharpened pencil, with the pencil point being used for all of them. And then critically evaluate the design of the experiment, suggesting 3 ways in which it could be improved or to increase its reliability and validity. Now remember that validity begins with a V, and it's all about fixing variables. Validity, variables being fixed. Reliability is all about repeats, because it begins with an R. So you could have given any possible answers. For example, and please bullet 3 different ones, because this one says 3 ways, and if you don't bullet 3 different ones, you get carried away and you do 20 of them, and 20 of them are done badly, and we're only allowed to look at the first 3 in any case. So there were only 5 subjects. The sample size was too small. It should be increased to many more, and then you must give a figure. Okay, we don't care what figure you give as long as it's a nice big figure. Okay, so 100. Okay, don't say it should be increased to more and then leave the examiner to decide how many more. Okay, or it was only done once, should be repeated 3 times. You must give a figure here. Again, don't leave it up to the person's imagination. Don't go, it should repeat it 2 or 3 times. I'm not going to fill in a figure for you. You've got to fill it in. And the figure So if you do it once and then you repeat it 3 times, remember you've got a total of 4, eh? It's not 3, it's 4. Once you repeat it 3 times, it's 4. And then you calculate an average per age group. Now, this is one example of where the IV might not let you give these two as the same. So they're both about repeating how many individuals and how many times you did it. That's both about reliability. And then it could be done on a range of subjects with a range of IV effects, which were not taken into account and should be done only on people without IV effects. Or you could have spoken about anything here. So for validity, remember fixed variables, you could have spoken about having it done at the same speed and then described a way in which you could have it being done in the same speed or done at the same, under the same light conditions, because obviously the intensity of the light could affect somebody's ability to see negatively if it's a low light intensity. Okay, all right. I hope you managed fine with this.